Elon Musk, the visionary behind SpaceX, posits that the journey to Mars aboard the Starship spacecraft, propelled by 39 Raptor engines, spans approximately 6 months. However, this extended duration may seem impractical for many, including NASA. Consequently, NASA has revealed plans for a novel propulsion system fueled by an alternative energy source. According to NASA, this new engine boasts enhanced power, heightened safety parameters, and the capability to expedite the transit to Mars compared to SpaceX's Raptor engines. But what distinguishes this engine from its predecessors, and why does NASA express such confidence in its superiority? While NASA has yet to disclose the specifics of this groundbreaking propulsion system, they assert that it can potentially reduce the journey to Mars to a mere 45 days, a claim that at first glance appears doubtful. Our exploration today will try to crack the intricacies of this innovative engine, shedding light on its technological advancements and the rationale behind NASA's relentless optimism regarding its efficacy. So, let's begin to explore NASA's Nuclear Thermal Rocket Project. In a recent presentation at the American Institute of Aeronautics and Astronautics Sci-Tech Forum and Exposition, NASA Administrator Bill Nelson made a groundbreaking announcement. He revealed NASA's ambitious work, developing a nuclear thermal rocket project. The term nuclear thermal rocket might sound like something straight out of science fiction, but let us explain it. You see, traditionally, the aerospace industry has relied on engines that burn chemicals like kerosene or liquid methane to propel spacecraft. But NASA is thinking outside the box here. They're revisiting an idea that first emerged in the 1960s, using nuclear energy to power rockets. Back then, they called it the NERVA engine design. The idea gained traction, especially after the successful landing on the moon. Visionaries like Wernher von Braun, the mastermind behind the Saturn V rocket, even proposed using nuclear energy to send humans to Mars. But alas, due to safety concerns and various governmental factors, the idea was shelved, and no nuclear thermal rocket ever made it beyond the drawing board. Fast forward to today, and NASA is again dusting off this concept. With advancements in technology and the intensifying space race, they're giving the nuclear thermal rocket another shot. But this time, they're teaming up with some heavy hitters, including the Defense Advanced Research Projects Agency, better known as DARPA. Together, they're on a mission to accelerate this project and bring it to fruition. So, what's the game plan? Well, NASA will focus on developing these nuclear rocket reactors and engines, and they've even given the engine a cool name, Draco, which stands for Demonstration Rocket for Agile Cislunar Operations. But what's so special about these nuclear thermal rockets? Well, they have the potential to revolutionize space travel. Unlike traditional chemical rockets with limited fuel capacity, and can only take us so far, nuclear thermal rockets offer significantly more power and efficiency. Imagine cutting down travel time to distant celestial bodies like Mars from months to weeks. That's the kind of leap in technology we're talking about here. Plus, with the Draco engine, NASA aims to demonstrate its capabilities in cislunar space, the region between Earth and the Moon, paving the way for future missions to the lunar surface and beyond. What about safety? After all, we're talking about nuclear energy here. Well, rest assured, NASA and DARPA are taking safety very seriously. They'll conduct rigorous testing and implement stringent safety protocols to ensure that these nuclear thermal rockets are potent and safe for crewed missions into space. NASA's bold vision for the future of space exploration is fueled by nuclear energy. It's a journey into the unknown, filled with challenges and uncertainties, but also with potential and promise. And with the Draco engine leading the way, who knows what wonders await us? The working of nuclear thermal engine. So, how does this fancy new nuclear thermal engine work? Traditional rocket engines rely on burning fuel, like kerosene or liquid methane, to create thrust. But the nuclear thermal engine operates on a whole different level. Instead of burning fuel, it harnesses the power of nuclear fission to generate intense heat. Inside the engine, there's a nuclear reactor that uses uranium atoms. These atoms are bombarded with free electrons, which causes them to split apart in nuclear fission. This split releases an enormous amount of energy and heats things big time. Like, we're talking temperatures up to 5,000 degrees Fahrenheit. This super hot reactor heats a special kind of fuel, liquid hydrogen. Liquid hydrogen is pumped through the reactor's core at incredibly high speeds. As it passes through, the extreme heat causes it to expand rapidly and turn into gas. This creates a ton of pressure released through the engine's nozzle, shooting out the back of the rocket and propelling it forward. It's like a controlled explosion, but way more efficient and powerful. But why liquid hydrogen? Well, hydrogen is the lightest element in the universe, which means it's super efficient for space travel. Plus, it's abundant and easy to find on Earth and in space. So using liquid hydrogen as fuel maximizes efficiency and ensures we have plenty of resources to sustain our missions into the depths of space. By harnessing the power of nuclear fission and liquid hydrogen, this innovative engine promises to revolutionize space travel, making it faster, safer, and more efficient than ever before. Advantages of NASA's nuclear thermal rocket project. Let's get into the advantages of this nuclear thermal rocket project and how it might shake things up in space travel. First, this new technology promises superior performance to conventional rocket engines. While we don't have specific data yet, experts estimate these nuclear thermal rockets could be 3 to 5 times more powerful. That means more thrust, which translates to faster journeys through space. NASA claims they could slash the trip to Mars down to just 45 days, a massive leap from the 6 months it would take with current technology. To put it in perspective, let's compare it to SpaceX's Starship, which is currently one of the most potent rockets out there. Elon Musk estimated it would take Starship 6 months to reach Mars. That's 4 times longer than NASA's estimate with the nuclear thermal engine. And why does this matter so much? Reducing travel time isn't just about convenience, it also solves many tricky problems. Think about it. Shorter journeys mean less time for things to go wrong. That means fewer headaches when controlling the spacecraft, managing fuel supplies, ensuring the crew's health and safety, and all that good stuff. Using a nuclear thermal engine also means we'll burn through less fuel. Instead of relying on chemical reactions like traditional engines, these bad boys run on nuclear fission. That means they don't need to carry as much liquid oxygen, a significant component of rocket fuel. And since liquid hydrogen is the fuel of choice for these nuclear thermal engines, and it's lightweight, efficient, and abundant in space, it's a win-win situation. Now let's talk about where things stand with the project. Details are still scarce, but the most recent update came in July when NASA and DARPA tapped Lockheed Martin to develop the Draco engine demo. This demo will showcase the capabilities of nuclear propulsion technologies in Earth's orbit, and it's slated for later this decade. Lockheed Martin is teaming up with BWX Technologies, a supplier of nuclear components and fuel, to make it happen. They aim to complete the work within the next few years and conduct the first test flight 2027. If all goes well, they're eyeing a crewed mission to Mars around 2030. Now, how does all of this affect SpaceX's plans to colonize Mars? Well, it's a mixed bag. On one hand, the nuclear thermal engine could give NASA a leg up in the race to Mars, potentially creating some competition for SpaceX. On the other hand, Elon Musk is supportive of the idea. He even tweeted about the potential benefits of nuclear thermal rockets for fast transit around the solar system in 2019. As for SpaceX's timeline, they're still plugging away at their Starship project. They've made significant progress with some integrated test flights in 2023, although they have yet to reach orbit. But they aim to land an unmanned Starship on Mars around 2027, with crewed missions to follow soon after. So while NASA's nuclear thermal engine might give SpaceX a run for its money in terms of travel time, Elon and his team are still working hard to improve their rockets. Plus, they've got some advantages, like their methane-powered engines, which are cleaner, cheaper, and easier to produce than nuclear thermal engines. Ultimately, both projects have their strengths and weaknesses, but they're both pushing the boundaries of space exploration, and they may even end up collaborating down the line to propel humanity even further into the cosmos. If you enjoyed this video and found it informative, give it a thumbs up and subscribe to our channel for more exciting content like this. Your support means the world to us as we continue to explore the wonders of science and technology together.